In this next video, what we're going to do is we're going to investigate inscribed angles that intercept the same arc. So remember, the theme of this entire lesson 9.3, is about inscribed angles. So we're going to be investigating different scenarios with inscribed angles. So the first thing we're going to do is construct a large circle and select 2 points on the circle, labeling them A and B. So I'm going to start with my center, and then I'm going to create my circle. Okay, so I'm going to label my points A and B. And we're going to select P on the major arc. So again, the major arc would be going this way. So we're just going to select a P. And then we're going to construct inscribed angle APB. So P, again, is our vertex point. I don't want this to be going quite through the center. So actually, I'm going to move P up to here. I'm going to move P to there. It might have gone through, it might not have, but that's okay. So there is my inscribed angle. And then with my protractor, I'm going to measure angle APB. And this should be nice enough to get through, but maybe not. I might have to extend my ray up here. All right, so this looks like it's about 39 degrees. So we'll say 39 degrees. And remember, if this is 39, then arc AB is double that measure. So it's going to be 78 degrees, just in case you were curious about that. So now we're going to select another point Q on arc APB. So again, here's arc APB, and we can select Q anywhere. So I'm going to select Q right down here. I could have put it here. It doesn't really matter. And now we're going to construct inscribed angle AQB. Again, Q is our vertex point. Okay. And then we are going to measure angle AQB. And if we do that correctly, yep, it looks like it's also 39. This one's a little bit closer to 40. Again, why does this make sense? Okay, so how does a measure of angle AQB compare with the measure of angle APB? They are equal. So the angle measures are equal, which means that they are congruent. We can also do this again, but make the angles more obtuse. So we can select the points Q and B over here. Why does this make sense? Well, a couple of reasons. Again, who's our intercepted arc? Our intercepted arc for both angles APB and angles AQB are arc AB. And so the measure of an inscribed angle, right, is half the measure of its intercepted arc. So if they intercept the same arc, then those inscribed angles should have the same measure. So that makes a lot of sense. So our conjecture says that inscribed angles that intercept the same arc are congruent. Okay, so let's take a look at this example. This is going to give us a bunch of, or we're going to continue to layer on some things that we've learned. So for example, what I'm noticing here is I'm noticing some inscribed angles, and I'm noticing I have arcs along my circle. I'm also noticing a set of congruent chords. And this is from earlier in chapter 9, where we know that congruent chords intercept the same arc. So that's going to tell us that S and Q are equal. So S is equal to Q. So that's going to come into play as well. I also see an angle here, and if this is 87 degrees, then I can use my vertical angle conjecture to conclude that that is 87. So I'm going to actually start with R, because I notice this 29-degree angle here, and I notice that this intercepts arc R. Like R is the intercepted arc here. So if I double 29, I get 58 degrees. So R is 58. And I'm also noticing that there is another inscribed angle along this arc. So if I go ahead and start with my endpoints of my intercepted arc and draw my fingers back along, that means this angle here is also 58 degrees. Now, why is that helpful? Because I have a triangle here, and I need to get the measure of arc P, which means I need to use my triangle sum, and then get this inscribed angle measure as well. And I don't have my calculator handy, so I'm just going to do some quick math. Oops, I'm sorry, this is not 58, this is 29. I forgot to divide by 2. So that's going to be 116, and then if I do 180 minus 116, that means this angle here is going to be 64 degrees, so then of course P would be double that, so P is 128. How am I going to get the measures of arcs Q and S? Well, I'm going to do double that. I'm going to call their measure X, so 2 times that because they're congruent, plus arc P, or the measure of that arc was 128, as well as the arc that had R in it, and that should equal 360 because my full circle is 360 degrees. Again, this would be a lot quicker with a calculator, but so 16, 186. That's okay. We can do a little math by hand today. That would be 8, 14, 87. So this is 87, and so is that. All right, and then we're going to do one more investigation in this video. In this video, we're going to investigate what happens when we inscribe an angle in a diameter. So again, let's construct a large circle. So I'm going to set my center point, put my stylus on that. Construct a beautiful circle, and then we want to make diameter AB, and so I'm just want to be careful here to get a line exactly through that center point, and I'm going to label one of those A and one of those B. We're going to inscribe 3 angles. You don't actually have to inscribe 3 angles, but I'll just pick 2 points. So I'll pick a point here, and then I will pick a point here. So a couple different things. First of all, we're going to construct the inscribed angles here. What do we remember about the last investigation we just did? Well, any angles that are inscribed in the same arc should be congruent. So I'm inscribing 2 angles here, and they both are intercepting arc AB. And so, of course, that makes sense that they would be congruent. But then now the question is, what is their measure? So we're going to go ahead and measure those. And if you feel like constructing a third, go for it. Well, look at that. Perfect 90 degrees. I guess I'll do it this way. Look at this one. Perfect 90 degrees. Now again, why does that make sense? Well, if this is 180 degrees because it's a diameter, it's a semicircle, which we know is a semicircle a semicircle is an arc whose endpoints are the diameter. And again, if this is our inscribed angle, well, that would be half of that, so that should be 90. What do you notice? They are 90 degrees. Sorry, we'll move that down there. They are 90 degrees. And so that conjecture, our inscribed angles in a semicircle conjecture, are angles inscribed in a semicircle are 90 degrees, or are right angles. Let's finish off with this example. So here I have a triangle. I have one arc given to me. And I also notice this is a diameter because the center of the circle is labeled. One thing that we should notice when we're reading a diagram is that we can't assume something is a diameter or something passes through the center unless the center is labeled in that circle, and it shows us that. So what I'm noticing here is that angle A is the angle inscribed in that diameter. So that, it's not really angle A, sorry. So A is 90 degrees. I'm also noticing that this is 70, this arc here, and C is going to be the measure of that inscribed angle. So that's going to be half of that. So that's going to be 35. And then B is my third angle here. And so I can either use triangle sum or I can use the fact that this is 180 and then subtract 70 from 180 is 110. And then I can go ahead and take half of that because B inscribes that, and that's 55. So there are multiple ways to approach a scenario where we have a lot of inscribed angles and some other conjectures. So great job with this part of this lesson.